Welcome to this Roundup. The World Wide Web and its ecosystem seems to have been initially aimed to share confidential information amongst trusted individuals. That was then. Now, the World Wide Web has fundamentally transformed the way we, the humans, live and do things. It has brought each individual and entity across nations, its government, industries, organizations, and academia, in short referred to as NGIOA, a global marketplace that is rapidly growing beyond the geographical boundaries. The digital products and services ranging from e-commerce to e-banking, voting, government, socialization, education to Internet of Things and more are increasing in numbers and already a reality across nations. As the digital global age witnesses transformative technological advances that is disrupting entities across NGIOA, uncountable transactions are already happening in the global marketplace every single day. And of course, protecting these digital records and transactions from corruption, manipulation, theft is of vital importance. Now, to be able to protect these digital transactions requires understanding of risk, where it comes from and how we can manage that. The critical security risk of web originate from each digital initiative, product and service that goes through World Wide Web or cyberspace. Understandably, security to all these initiatives, products, services, and applications on web is now a cause of great concern. As the web expands and goes beyond the close-knit circle of trusted individuals to global, the fundamental trust between the users disappears. In other words, with the fading trust, everyone using the web is now vulnerable to its security risk. Security is rapidly becoming a myth. Now, some may say that let's not digitalize or be on the World Wide Web. Is that even an option today for any individual or entity across NGIOA? Can any individual or entity across NGIOA survive and sustain without going digital in a digital global age? To discuss this further, I'm delighted to welcome Andre de Castro, CEO and founder at Blockchain of Things. Welcome, Andre. We are delighted to have you on this Roundup.
Thank you, Jayshree. I'm delighted to be here.
Wonderful, Andre. So there is a growing belief that the blockchain technology that conducts and secures transactions on the Bitcoin network and makes them transparent to the prying eyes of unwanted people or entities now can be used to process complex financial and non-financial transactions and to securely store and transfer any kind of digital information on the internet. Do you think that the blockchain technology will work beyond Bitcoin?
Absolutely, absolutely. So Bitcoin brought us something very, very interesting, which is a secure infrastructure to transfer value. And that value transference infrastructure has proven something very, very fundamental in the last 8 years. And that is, never has a transaction of any value, be it $1 or $100 million that we've seen be sent from one individual's wallet or an application to another individual's wallet to another application, has it ever been subverted. So corporations should take notice that there is an infrastructure that exists in the world with a $10 billion hacking incentive, and no one has been able to subvert a transaction from point of origin to point of destination. So when we think of that, and we think of the power of the transaction on the Bitcoin protocol, we have to sit back and start wondering, why hasn't corporations caught on to this? And the answer is pretty simple. I think many are starting to realize the power of the infrastructure. However, connecting to blockchain technology is not as easy as one would think. Blockchain and Bitcoin technology has its own nomenclature, has its own ideas and primitives that even some of the best computer scientists in the world take time to understand and adapt to. And that's where my company comes into focus. We're trying to bring this ability to secure a communication from point of origin to point of destination that has been already proven throughout 8 years with a $10 billion bounty for hackers and government states to take down, and they've never been able to do so. So why is it that there are devices throughout the world connected to the internet in what we know of as the Internet of Things, or rather the Internet of Everything, yet hacking, man-in-the-middle attacks, and different attack vectors between transmissions between point A and point B every day are compromised? We're bringing to the world the ability to connect. Of course, there's an additional fee when you're using the Bitcoin blockchain and other blockchains, but we're bringing to the world the ability for companies to easily integrate into this infrastructure with high value items and never concern themselves based on a proven system that now transfers value. We will be transferring messages and ensuring from the highest military to the lowest hanging fruit could be somebody's home that we can protect end to end by using this proven technology.
That's really, good. I'm really glad to hear that. Now, this technology, you are saying the infrastructure, the companies just have to come and integrate. So is that one single infrastructure that everyone is using across nations, or we have many parallel, blockchain of Bitcoin kind of infrastructure, working in parallel?
Well, that's very good. That's a very good question. So we were brought to blockchain by Bitcoin technology. And today, the strongest computational network known to man is the Bitcoin technology infrastructure, right? So these are all of the full nodes and miners throughout the world, and that's vast. It's a vast infrastructure network. Now, because it's a vast infrastructure network, it comes transactions or messages sent on this infrastructure come at a cost, right? It could be a very high cost depending on what connectivity you want, but it's in the 10, 15 cent type cost. And that could be very, very high. Maybe not to protect a high value item on a smart grid, for instance. Maybe that's a very inexpensive cost, depending on the business application. But there are other blockchains that exist that are much less expensive. It's the reason why the product in my company is called Catenis. Catenis is Latin for chains. So the intention of the product is to first support the best known blockchain in the world, which is the Bitcoin blockchain with the largest infrastructure. And in time, we will support competing chains that will give you additional functionality or different functionality, or lower costs, depending on the implementation. Now, if you want the strongest, most proven blockchain infrastructure in the world, you'd choose to use the Bitcoin blockchain. And that's the first iteration of our product.
Good to know that. Now, so this means that the blockchain technology could provide or would be able to provide a way to secure, a way to track each and every individual physical device, each and every individual Internet of Things or devices that are emerging and growing so rapidly by recording an archive of data exchanges between different IoTs and other devices, web service, and even human users. So based on your observation, what advances are made to secure Internet of Things using blockchain technology?
Well, so I think you touch on three topics. I think you touch on the topic of device address and registration, right? You touch on the topic of the capability of actually housing all of this information, right, from a regulatory perspective, because blockchains are immutable in nature, right? So let's first address those two, and then we'll address one more. Initially, we have to see that the infrastructure allows us to take advantage of it, right, for everybody, which means that we don't have costs with servers if we're talking about the Bitcoin blockchain itself, right? It's a free global infrastructure. The information that is sent between point A and point B, the reason why it's so secure is that before any transaction is sent, it's cryptographically signed. And when it arrives at the other point, its signature is verified that it could have only been sent from the originating point, right? Now, you could send as many messages or try to do the best you can with a man-in-the-middle attack between those two connections, but you'll never be able to sign, cryptographically sign that message, so the verification will fail, right? So that's why we get a tremendous amount of security. But at the same time, because we're sending the message across the global blockchain, we get recorded onto the blockchain the information itself, right? So that's the information that we can use for governance. So when we're doing governmental systems or banking systems or anything in a regulatory space in the industry, now we have 100% traceability of everything that occurred. And that's very, very important, right? But at the same time, you want security, right? You may send a message, but you may not want to have that message be seen by everybody for it not to be in clear text. And that's where you need to add some functionality to standard blockchains. And that's where a company like our own comes in. And we allow automatic encryption using the public-private key infrastructure that exists on the blockchain to actually encrypt the messages themselves, right? So not only do we have governance, but we have protected governance because each message is encrypted with the highest grade of security. With Catenis, for instance, we adhere to military-grade security, what's called perfect forward secrecy, meaning that every thread of every message that goes between point A and point B gets encrypted with a different private key. So if you were to compromise a key, you could never read a thread that happened prior to that thread or after that thread, right? You would only get one thread of communication, which is how military-grade communication works. It's called perfect forward secrecy. Blockchains do a great job at cryptographic signature verification, but they don't contain encryption. So we've also added an encryption layer, making this the ability to have the type of governance that you've brought up, the ability to send the message and ensure that no one can subvert or jump in the middle of that message and replay it as themselves, and additionally encrypting it, so obfuscating the information that's within the message itself, right? So we get protection, we get secure verification, and we get governance for regulatory purposes on the chain at the same time. These are things that traditional systems would have a very, very hard time doing, and blockchains facilitate that, right?
Yes.
Of course, you may need some additional layers on top of that, and that's what a company like Blockchain of Things is bringing to market with the Catenis Enterprise product.
Yes, that is such an impressive. I mean, we get all these, variables that we are looking at, like you said, governance and security and everything, functionality. We get all of that in one chain. So that is really pretty amazing. It is also believed by many that blockchains could also enable smart devices to become independent agents and autonomously conduct a variety of transactions on its own and becomes more like it's an individual corporation that doesn't require humans to be part of it. So what kind of innovations are we looking at?
Well, I think quite a few. First, we have to understand the nature of a blockchain, right? So Gartner predicts that by the end of the year, we may have 20 to 50 billion devices connected to the IoT. Now, that becomes a very interesting question. How do you register and maintain all of those devices? Well, one of the unique features of blockchains is that blockchains have unique addresses up to 2 to the power of 106 addresses on the chain itself. So at the end of the day, we have an unlimited amount of addresses. To put that into perspective, the planet Earth is said to have 2 to the power of 63 grains of sand, right? So we can have many, many planets worth of grains of sand registered on the blockchain. Now, these blockchain addresses are unique, and what's really interesting about them is that they work on a peer-to-peer nature, so they're directly addressable to each other. So you have a ability to send a message between 2 points when you know the address and speak directly to each other. When you have the ability to do peer-to-peer communication, then a device can contain a program and be triggered. You can send events to it. You can send information to trigger the program itself. And the program now becomes autonomous. So you can imagine now a drone or a vending machine having a blockchain address, and a company being able to trigger things for the drone to do or for the vending machine to do from any part of the world near instantly. And that becomes very, very important for these autonomous programs. And these autonomous programs are known as smart contracts. Now, there are many ways to do smart contracts, right? There are blockchains out there that do smart contracts that live on computers that the company doesn't necessarily control. They're on mining computers. Etherium is an example of that. And there are ways to do these autonomous contracts directly on the blockchain where the corporation controls the source code and the source code is compiled at the point of origin or point of destination, be it a drone or a vending machine. And Catenis allows that to occur via the standard Bitcoin blockchain. So the contracts are actually executing in real time at the speed of the processor, and all of the source code executing on these autonomous programs are written in the language of choice of the company and compiled. So it's a much more robust way of approaching smart contracts and much more secure than some of the infrastructures that are trying to build smart contracts that actually live on mining rigs where you don't control the speed of the processor and you're very, very slow. So our approach is a little bit different. I think what we're producing maps a little more directly to corporate needs, but again, it's a different approach, and there are uses for both of them.
That's very good analysis. And now, what are the blockchain applications? If we are looking only at IoT, that is Internet of Things and smart systems, what are the blockchain applications that are already available and currently in the market from your observations?
Well, there are some. A lot of them are starting to break away from the financial aspect, right? So some of the better known applications tend to be around using Bitcoin as either a currency or a commodity of some sort. So there are applications for trading Bitcoins and things of that nature. Now we're starting to see an emergence of a different type of application, and that's application for registering individuals' identities on the blockchain, applications for doing provenance or proof of origin of products, applications in all sorts of different realms that will start using the power of the blockchain itself, right? However, when we start looking at these applications, we start realizing that these small companies that are emerging are taking years or better to implement or build applications on this infrastructure. And that's what we plan to change. Blockchain of Things fundamentally wants to allow any corporation or any software engineer that doesn't necessarily have the blockchain skills to be able to use standard web service interfaces, to be able to build applications quickly and get to market faster. And that's our full intention, right?
Good.
So as we evolve and blockchain technology evolves, I think we're going to see more and more innovative applications using the infrastructure of the blockchain, using autonomous contracts, and something we still haven't touched on, which is the asset capabilities of blockchain technology.
Right, right. Now, it's believed that as more devices or more Internet of Things or more humans they get on the blockchain and join in mining, the security of the entire blockchain based network increases as a result. So can you explain that phenomenon, which is the underlying reason why as more people, as more into Internet of Things devices are getting on the Bitcoin chain, I mean blockchain network, that the security of the entire chain increases? What is the reason behind that?
Yeah, well, that's an interesting question. So we have to go back to understand how blockchain and Bitcoin technology works. And there's no central authority, right? So what you really have is a lot of individuals throughout the world running full nodes and mining rigs. And these mining rigs actually confirm the transactions. For whenever a transaction is sent from individual A to individual B, what they're actually doing is verifying that the individual who sent the money from point A could have only been the individual who owned the money that he or she sent, right? So what they do is they verify this cryptographic signature that gets sent. When they verify these signatures, there is a puzzle that they have to solve. And this puzzle can only be solved with a lot of computational speed through brute force. When they solve this puzzle, they get rewarded, right? It's called solving a block. They get rewarded with the cryptocurrency, with Bitcoin. So there's an incentive to solve it. So what that does is it creates a virtual arms race of processors where one miner wants to find more blocks quicker than another one. So they buy more and more processing power. And as they buy more and more processing power, the infrastructure, the blockchain infrastructure, what it does is it balances itself out. So it only allows you to find the block on average every 10 minutes. So if you have more processor power, it increases the difficulty of finding the block, right? If you have less processing power, it decreases the difficulty. So what winds up happening is that you have competition, and this competition builds for more and more processing power on the network. And today we have the Bitcoin network being the largest single computational network on the planet because of this competition. And in having all of this, it increases the security by this virtue of competition on the network. So all of these rigs, right, and have to come to consensus that that transaction was a proper transaction. And this builds into the security of the infrastructure. So the bigger it gets, the more secure it gets, right?
Yes, yes, very true. Now, there are some who believes that the future of the World Wide Web or Internet looks a lot like Bitcoin. Do you think that there would be fundamental, redesigning of the Internet or the World Wide Web based on the blockchain technology? Do you see that possibility happening?
Well, that's an interesting question. Now, I'm not here to predict the future, and that's very, very difficult to do. But I can say that blockchain technology is significant and will grow, and it's probably as significant or as impactful as the internet has been to us in the last 20 years, right? So we're going to see similar types of impact. And we're also going to see the internet morph or adapt blockchain and blockchain protocols more and more across time. I can't tell you exactly how deep this Venn diagram of overlap will be, but I know that there will be a emergence of technologies. But remember, not every technology is suited for everything. And I would say the same for blockchain technology. Is it suited for everything? Can it solve every problem in the world? The answer is no. What it will bring to the world is a very powerful landscape online that we don't have today. And that's significant for every company to take notice and every company to look at different projects on how they can leverage this technology. And that's what we're here for. We're always available to answer questions and help any corporation that's looking to integrate into blockchain technology.
Yes. Now, it is said that blockchain is very efficient and can easily fix the data ownership and data transfer security risks that we are all, witnessing, everyone, facing currently. Can you explain how this technology, from your perspective, could manage or eliminate the data ownership risk that a lot of people are worried about going to the clouds, that there will be a time that we would have to probably hire a lawyer to prove that this is our data. So how can blockchain technology minimize those kind of risks from your perspective?
Yeah, well, that's an interesting question because the premise goes down to how the technology works, right? So today in cryptocurrency or Bitcoin, you prove ownership through signing by using a private key. So the private key with this private public key infrastructure that exists within the blockchain, you can always prove that you're the rightful owner. Right? So applying this methodology to cloud infrastructure becomes natural for ownership of data. If I have the key and I can sign and prove that I'm the owner, then I can sign and prove not only that I'm the owner of cryptocurrency, but I'm the owner of data. Because ultimately, under the covers, when we talk about Bitcoin and cryptocurrencies, they're just sequences of numbers. They're just data anyway. Right? So if you can prove through a cryptographic signature that you own that coin, you can also prove that you own the data itself. And in a distributed fashion, you can now have data ownership throughout the world housed very, very securely.
Yes.
And always prove it's yours.
Right, right. Now it seems that all miners work independently on this Bitcoin kind of networks, blockchain networks on their own version of the blockchain. Now, when they finish a new block, they broadcast it to the rest of their peers or the rest of the people who are working. They check it, they accept it, and add it to the end of the chain and pick up their work, and they pick up the work from this new starting point. Now, this arrangement will work only if the miners agree on what the most recent version of the blockchain should look like. They all need to be in agreement. Now, in other words, they all have to agree on a consensus version of it. But given the fact that they all are strangers, they don't know each other personally or professionally, they don't know who the other parties are. They really have no reason to trust one another's work. So what is to stop a miner, or what would stop a miner from hoaxing with earlier entries of the blockchain and undoing payments or any other nature of transaction that is going on?
Well, that's a great question. And that's a question, that one would ask with traditional technology. With a blockchain, it's impossible, even for the owners of the node, to change anything. Because whenever transactions are sent, they're cryptographically hashed. And whenever a block is found, it's cryptographically hashed. And its hash is included in the next block, creating a chain, right? So node owners and mining rigs are unable to go in and modify anything, right? The only time a block gets onto the blockchain itself is if you have a consensus throughout everyone. Everyone agrees on all of those transactions. So there's no one individual who can subvert based on some selfish reason. And because no one miner can subvert information, because the information that gets included has to have consensus or have everybody agree in a massive scale, then it becomes very secure. And because once the block is in, it's impossible to reverse, meaning it's immutable for eternity, no one can touch any of the information. The only way information gets onto the blockchain is if a massive amount of individuals agree. And once it's in, it's unchangeable.
That,
And that's
that
how it functions.
that is good that we have the system. So it seems that the blockchain model has the potential to fix cybersecurity challenges. Now, from your observation, what are the efforts ongoing towards using this technology to secure cyberspace?
Well, I think we're trying to solve some of the challenges, and some of the challenges today have to do with holding keys, public-private keys, and securing them. Another one is that even though you may want to build an application on the blockchain, right? And let's say you're a corporation and you want to build an application on the blockchain today. What do you have to do? You have to buy cryptocurrency. Let's use Bitcoin, for instance. You might have to buy thousands of dollars worth of Bitcoin and then give that to your IT department or your developer to be able to use the coins to submit underlying transactions. Well, that model doesn't necessarily function with the way companies work today. It's unlikely that the finance department of a company is going to give a blank check to some individual in IT, right? Or a blank check to some developer in the development group. So, and because of that, innovative companies like our own have abstracted out the cryptocurrency from the transaction and transactional messaging, allowing a company to go and purchase with a credit card or a purchase order 1,000 to 2,000 transactions, right? We call them catenas messages, and give those messages with our virtual devices to the developer. The developer can use the APIs that we provide to build however he wants and deduct from the messages. But there's no cryptocurrency to be stolen. There's no cryptocurrency to be mismanaged, right, within a company. So those are the types of things that will allow industry to leverage this technology more and more. And it's the reason why we're bringing Catenas Enterprise to market.
Right. No, that is true. Now, blockchain timestamp, it seems that it's going to be very useful to developing application for many fields. What are your thoughts on that? Because I think that timestamp is going to be very critical, right?
Yeah, I would agree with you. The timestamp is critical because when you couple the timestamp with immutable information, you get an automatic notary, right? So everything you do now is notarized by using math and physics. Think about that. We only spend today the time to notarize things that we believe could possibly be contested in court one day. And lots of times, there's much more arbitration that occurs, or lawsuits, if you will, because a lot of the things that we do on a day-to-day basis is not notarized. We don't have a third-party independent source verifying what occurred. Once you start using blockchain technology, you're automatically getting a third-party verification, right? That's automatically being done on everything you're doing, from messaging to asset transfers to smart properties to contract execution. So that timestamp itself becomes critical, right? And I think it will, over time, decrease the need for arbitration or for lawsuits, because there will be recorded record of things that we take for granted, right? Today, one would never consider using a notary for a message between two devices. We're using a notary for traditional computer interaction or application interaction. Imagine when we have that type of proof being done automatically for us. We significantly change the playing field, even when it comes to, you know, human arguments and any type of situation where two parties don't agree.
Yes, that is true. That is very true. Now, it also seems that with the blockchain, we will be able to replace the standard username password that we all are using, currently. So, do you think that, that would become, that would fundamentally change many aspects of security? Because right now, username password, is the main source of, many people hackers are able to get into the unauthorized systems where they are not supposed to be there. So with blockchain, we'll be able to replace the standard username password security challenges that are coming our way, right?
Yeah, I think, we sit back and we think username passwords that we have today, and they're very, very insecure, very insecure. When I think of a future of authentication, and of course this, authenticating by using blockchain technology is probably a little bit into the future, because a lot of systems would have to adapt, right? And of course, there are players in the field already providing solutions for that. And it basically works that you always have your private key with you and you sign a message. And if you can sign that message with your private key, you can prove who you are. If you've proven who you are, then you can get into the system, and no one else can sign that message. Now, the importance of this is that your private key is never transmitted. Since it's never transmitted, or the website or application you're trying to get into doesn't have a copy of it, right? It's impossible for that website to be hacked or anything to be stolen from that site, right? Which is the importance of what we're doing. What we're doing is we're building this infrastructure to allow people to leverage this signing capability and prove that the message came from them. And
Yes.
that will revolutionize security using username and passwords in general.
Yes,
I do believe that it will take time, right? Because the infrastructure that we use for username and password is vast today, and it takes a lot of time for companies to change. But it's a logical progression in security.
Yes, very true. Now let's talk about multi-signature transactions. It seems that it will let users divide ownership of a Bitcoin address or a blockchain address among many people by assigning it multiple private keys. Now, many companies have emerged, it seems, that are specifically offering escrow services based on multi-signature transactions. Where do you see the application of multi-signature transaction going forward?
Well, it's a big question. It's a big question you ask, because multi-signature transactions, right? It also sort of does what the infrastructure does, and it allows two parties that don't even know each other to do business. And the applications of multi-signature transactions, I believe, are vast, right? So today, in the cryptocurrency space, people use multi-signature transactions to ensure that a payment gets sent, or that you have an arbitrator if something goes wrong with a payment from party A to party B, or they use it for security perspective. But like was mentioned prior, cryptocurrency is data. And now you could do that, and data can represent anything from art to, a representation of a physical item, right? So now, if you can tie the ability to sign a transaction and prove that you are who you are, and that gets tied to a key of a car, Now you can enable the use of that car or not. With a third-party signature, you could have the leasing company hold the key, right? And the leasing company and the seller of the car can possibly override you if you haven't paid for the lease of your car.
Yeah.
Or if you have paid, right, you could override the other party who doesn't want you to have control. So the applications are vast,
Yes. So
vast with the
it's,
use of multi-signatures.
yes.
I think it's applicable today. We're applying it to value. Tomorrow, I think we're going to be applying it to many, many, many,
Yes.
many aspects of industry.
Yes. So it seems. Now it seems a new kind of internet is being built by Ethereum. Can you share the details about it? Because it seems that it is able to override some of the limitations of the Bitcoin kind of network, and it is giving miners some really uh, many new commands to execute while validating transactions. So it's giving a lot of features that a lot of miners really like. So what can you share about Ethereum and the advances that they have made, and where it stands today?
By no way do I consider myself the Ethereum expert, and I think Ethereum is a very, very ambitious project. Um, the founders of Ethereum have had a vision. It's an ambitious vision. I think the product today is still a bit immature for industry to adopt it, right? One of the positive values of Bitcoin itself, and let's keep in mind that Ethereum is fundamentally different from Bitcoin from a technological perspective. Ethereum borrowed some of the best known mechanisms of the Bitcoin protocol and added to Ethereum and changed significantly quite a lot of the fundamental inner workings of it. And they have a vision where contracts or these programs that work by themselves can run all over the world and not be taken down by anyone. But, that was their vision, and recently they've proved the opposite. They went out of their way to do something we call rewriting history. I think that corporations today, if they look at the Ethereum project, will see the Ethereum project more like a testing ground for new technologies going forward. If I were the CEO of a company, I wouldn't consider it as a serious alternative, not at least not at where the technology is today. The Ethereum Foundation themselves have proven that their actions, right, could have impacted any companies using the network itself, right? So from a reliability perspective, the choices that they made, I don't believe are the best. But that's okay because they're striving for even better and better technology going forward. And in time, right, it took 8 years for industry to start recognizing Bitcoin technology. Ethereum was recently released. So maybe in 7 years, we'll look at Ethereum differently and we'll start embracing the vision that it's bringing to market. I think it's a little too early on. I'm a software veteran of 28 years, and I've seen the evolution of software, even the largest companies from Microsoft to Oracle. It takes, between 6 to 10 years for software to mature. And I think they're just going through that standard cycle. But they do have a very ambitious vision, and I hope that sooner than later they can bring to market something that corporations can take it a little bit serious, a little bit more serious.
Yes, yes. Now, I also read somewhere that company called Filament is also investing very heavily in IoT and blockchain with a focus on industrial applications such as agriculture, manufacturing, oil and gas. Do you know any Anything about what is the status of their application and how advanced they are?
No, I don't. What I do know is, and I've done a little bit of research on Filament, and I, applaud the guys over at Filament because they have a similar vision to what Blockchain of Things does, but there's a significant difference. I think they're only using the blockchain to register device names, yet they call themselves a blockchain company, which I find odd. They're using different peer-to-peer technology. A lot of what they're using really isn't standard blockchain technology itself. Our stack is all built on the Bitcoin blockchain. The reason why we've been working on it for 2.5 years and only intend on releasing the product towards the end of this year or the beginning of next year in January 2017, although we are working with companies presently, and if there are any companies listening to this podcast, they can reach out to us, and we are working on projects. We just aren't going to release the squeaky clean interfaces. We have APIs and the ability to integrate, but we are all of our infrastructure is blockchain technology, right? We're not using some third-party infrastructure to do peer-to-peer communication. And I believe Filament is, and I believe even they plan on launching their own blockchain for partial functionality of it. Again, I'm not a Filament expert. I think I applaud them. I think what they're doing is probably fantastic in many, many ways. But the way I understand it is that they're only using a very, very, very small portion of blockchain, although they label themselves as a blockchain company.
I see. So which other companies are leading in the development of blockchain-powered IoT? Other than, of course, your organization is working on it, and Filament we talked about. What other companies are in the market?
I hear of companies talk about this, right? Small startups. The challenge with IoT is that everything can be IoT, right? IoT is a loaded word. So those specifically labeling themselves as IoT companies, I don't see many. So I'd love to speak to them. I think, the company that's more advanced with a product geared towards the IoT that leverages some blockchain capabilities would probably be Filament, right? That we just spoke of. But aside from them, I don't know of many. But I don't research other IoT companies. I stay focused on what we're doing, and I think we're leading the pack when it comes to this, and they'll follow our lead as we go forward.
That is good. Now, from your efforts with your company, your organization in blockchain of things, what challenges technical, non-technical challenges, you still think that remain to make your initiative, successful from your perspective?
Education. It's the reason why I do this podcast and I speak a lot to audiences throughout. Most people aren't familiar with what the power of blockchain and what it can bring to industry. I think we're spreading the words as we go along, but evangelizing the technology and the technology stack itself is very, very important. And I think that's the largest challenge today. But over time, everybody will start realizing the power of this infrastructure and how important it is to industry itself.
Yes, very true, very true. Education is the key. So would you feel comfortable saying that blockchains are in a position to change the world as we see today?
Yes, I think many, many industries will morph, right? How significantly they will change? Industries change. We watched a radical industry change, the music industry. I think that the financial industry will morph from what it is today. There will be a lot of the same players, maybe using different technology. Some of them may die and others will appear. So there are many, many industries that are about to morph because of blockchain technology. Again, I don't like to try to predict the future because you can only be wrong with that, right? But it will be impactful in many ways.
Yes, very true. Now, for a blockchain to be relevant, what is necessary? Of course, we have to educate for people to, accept this technology. Education is the key, but to be relevant, I mean, there are a lot of parallel other technology developments that are happening that could, I mean, in my assessment, it seems that, blockchain seems to be very relevant, and that would play a big critical role in the security aspect. And ensuring that all these initiatives that we are developing could be effective in the way we want it to be effective. But what other challenges do you see blockchain facing to be relevant today?
So we talked a little bit about knowledge, right? The education, but I believe the biggest barrier to entry today is integrating into blockchain technology. It's very, very difficult to integrate into, right? And unless we have easier software layers to be able to take advantage of the power of the blockchain, it's going to be tough for industries to adapt and use it. And that's exactly why we're coming to market. We're coming to market to lower that barrier. So understanding what it can do for industry and then being able to leverage it at the speed of business, I think are the two largest challenges, right? We're all trying to address the understanding, and companies like my own are trying to address the speed to market for corporations.
Yes, yes. Now, your organization, Blockchain of Things, can you share some information about it so our global viewers and listeners, if they like to, get more information or get in touch with you, or for them to understand what your initiatives are and how would it help the individuals as well as entities across, NGIA, so that, they have better information about your organization?
Absolutely, absolutely. You can go to www.blockchainofthings.com. You can follow our page on LinkedIn. Just search for Blockchain of Things, and also our page on Facebook. Or you can follow us at Blockchain OT on Twitter. What the stage we're at right now is we're at funding stages. So if there's anyone online who is interested in getting involved with a revolutionary startup and looking to is an investor or venture capitalist who's interested in the technology that we're bringing to market, we are going through funding rounds as we speak. We are a team of technologists who started this company, extreme blockchain enthusiasts, right? Some of us have a little bit of white hair, right? So we're not a company made up of young guys right out of college. We have experience selling to enterprise, and that's what we're trying to bring to the market itself. If any of your viewers are involved in a blockchain project and want us to do an assessment, they can feel free to reach out to us at any time. If they're looking to understand our technology itself, if it's a relevant project and we feel it's a relevant project, we will get involved directly. They can use our APIs even prior to our product launch, right? So we want to launch with a refined product, a product that has been tested and tried in different organizations. So we will welcome anyone who reaches out to us and is interested in leveraging our technology. Of course, it's alpha, it's pre-launch, but we're available if they believe what we're doing is relevant to their use case.
Great, that is wonderful, and I'm sure our global viewers and listeners would want to get more information, and they would reach out to your entity or website through any contact details that are on that directly. So, Andre, thank you so much for taking time out of your busy schedule and participating in Risk Roundup and sharing your views and insight into this amazing world of blockchain. That I think it is transformative, and we will see a lot of developments, a lot of innovations coming out of that, and most importantly, it would provide a really good infrastructure for security, which is what we all are looking for right now. So thank you so much, Andre, for participating in Risk Roundup.
Thank you, Jayshree.
Wonderful, Andre. So these ongoing advances in multi-devices computing, which comprises wearable computing, Internet of Things, sensors, tablets, laptops, smartphones, smart cars, smart cities, and more, brings critical security risk to each individual and entity across NGIOA. It is increasingly becoming clear that blockchain will likely be the answer to some of the most complex problems of not only the likes of fast evolving Internet of Things industry, but most of the independent and interdependent security risk originating independently and collectively from cyberspace, geospace, and space. As we explore the development of a digital future resistant to security vulnerabilities to protect not only individuals and we the humans, but entities across NGIOA, Risk Group Cybersecurity Risk Research Center and Strategic Security Risk Research Center are created for this very reason, so that we can collectively identify, evaluate, and manage the risk facing NGIOA in CGS. That means nations, its government, industries, organizations, academia in cyberspace, geospace, and space. And we can discuss, debate, and define necessary framework, structure, processes, tools, and technologies to manage the security risk of not only the digital global age, but also of the coming technological superconvergence. We at Risk Group believe that risk management, security, and peace, they walk together hand in hand. Though security is related to management of threats and peace to the management of conflict, risk management is related to management of security vulnerabilities as well as management of conflict. It is not possible to conceive any one of the three without the existence of the other two. All three concepts feed into each other. We believe that the security we build for ourselves is precarious and uncertain until it is secure for everyone across nations. Tradition becomes our security. So if you build a culture of managing risk effectively, it will lead us to security, and security will lead us to peace. Let's manage the existing and emerging risks together. For more information on the Risk Roundups, to watch the Risk Roundup videos or hear the Risk Roundup podcast, please go to riskgroupllc.com and do not forget to subscribe and share. Until next time, I'm Jayshree Pandya, host of Risk Roundup, signing off. See you next time. Thank you.